for me, kind of. But yeah, so I work with my wife, Miu, who's at the back there, and the little boy shouting is Joe, our son. So we met here in London back in 2014, and we got married, and then we moved to Tokyo, and we have a studio in Tokyo called Rich and Miu, and we work in shows, events, installations. We use multiple tools, but TouchDesigner is kind of our main tool that we use for creating our shows and events and so on. So I should have probably been on that slide first. This is us, and we founded the studio in 2019. And one of the things that we like to play with a lot is we like to play with patterns and sort of structures in nature. So we do a lot of work with natural forms and then kind of bringing that into the digital realm through different mediums and creating interactive installations and so on from that and artworks. So I'll just talk a little bit about our work before I go into the Mutek thing, so just show a couple of recent projects that we've worked on. So this one up here is for Shiseido. This is interactive immersive room using particles. And this is all built in TouchDesigner, and we were basically taking a GLSL approach to what is now the POPs workflow. So it was kind of, it's slow and cumbersome to build GLSL shaders and get like particle systems running. So this project here, like rebuilding that is kind of more efficient now, and I'm kind of going to talk a little bit about that later, about how POPs is this whole new paradigm that's going to help make things a lot quicker. So we did Shiseido's like in old TouchDesigner. So is this Oasis project. This is in Montreal. I believe it's still running. I think you can still go see it. It's called, it's changed its name about 4 times. I think it's called Nature Vive or Root for Nature. And this is in the Oasis, which is near the, I can't remember what the cathedral's called, but it's just down the road from there. So yeah, you can go see this one, I think, still. And it's a lot of nature footage and interviews with people about the environment and environmental catastrophe and so on. So this is all interactive as well, like multiple projector interactive installation. And then recently we've been working with Nike. So we have this interactive game we made with Nike. So it's all TouchDesigner to track people on the floor using Hokio sensors and that kind of thing. And then back up here is a project we did with Marcus, who's in the room somewhere. Oh, he's right there at the front. So yeah, Marcus, we did a technical direction with Marcus on Chemical Brothers for one of the songs, Live Again, on their on their new tour. And then that also expanded into an immersive kind of space for Smith and Lyle as well. So yeah, so those are some of the projects we've done in the past. Recently, probably in the last year, maybe year and a half. So we got introduced to Mutek very early on when we moved to Japan. We met some of the Mutek organizers, and they introduced us to Cara-Lise Coverdale, who is a electronic slash. She actually started out as like an organ player in a church, and now she's making her own electronic music and using Logic and other tools and so on, playing lots of instruments and stuff. So she's really great. The music's fantastic. It's very beautiful, very ambient kind of electronic music. So we ended up being introduced, and she wanted to work with us. And she had this idea that we were like, what, you've seen our work in the past, and what would you like to work on? Like, what kind of idea would you have? And we had this idea together of coming up with like this night forest and creatures in the night, or things that are in your peripheral vision and kind of hiding in the dark, but things that are not quite perceptible. It's like, it's very dark. You're kind of just making out the shapes and the outlines of these creatures or the flora and fauna in the forest. So yeah, we came up with this idea of this. The show was going to be around that, essentially. So it was a 45-minute set, and we decided, like, maybe me and you kind of, before we had the set, we kind of broke it down into, like, maybe we do different acts and have different sort of sections that have different themes. So we're talking about, at the beginning, we're going to go from evening down into the dark and into the nighttime, and then we're going to go into the forest, and then we're going to look at the macrocosm of the forest, like these kind of little details in there. And then we'll start looking at the fauna, so like what animals and creatures are living in this forest. Look at analyzing the creatures, so maybe looking at their movement and the color and the kind of, how creatures essentially communicate and so on as well. So we looked at those kind of ideas. And at the end, we'll go back into like pure darkness. So that was kind of the overarching sort of timeline that we had. So I'm going to show just this is like a 5-minute, 6-minute clip of the show so you guys can get an idea. So hopefully Ollie's ready with the audio in case it's too loud. So yeah, so that was all made using what I would call an earlier version of Pops. So obviously things have improved a lot since then. So what I wanted to do today is I wanted to dive into that show and show you that show, but obviously because Pops have changed so much, it didn't really make much sense. So I'm going to show you some examples, but before that, I'll just talk a little bit about how we get these scans and so on. So we were doing a lot of scanning in order to get the trees and so on in that first section. And we used our phones. Sometimes we had LiDAR, or we had other apps or whatever. Some of them were Gaussian splats that we then converted in Cloud Compare and then kind of put them together and brought them into TouchDesigner as point clouds. So it's mainly point cloud data. So that was our first sort of. We started doing some scanning. We used found footage. So this is like we have these two edits we created, which were built a forest that we could then create particles on top of, or create kind of graphical elements as well on top of this found footage. So in the first edit, we have it going from evening into the dark, and then in the second edit, it's more about the animals in the forest and some of the plant life at a closer look. So you can see here, we've got like spiders, owls, moths, kind of more typical creatures of the night in there as well. So we also, one of the other techniques we did is we used depth analysis. So we basically took depth maps of imagery, found imagery, and we then converted those into pops and used them as 3D point clouds, essentially. Even though they're not 3D sources, we converted them into 3D sources using, well, I guess you could say depth maps are AI, but yeah, I mean, just creating depths out of those. So we had these different sets of animals. So this slide here, actually, this is Miu telling me, like, hey, this is what we want to do, and this is what we want to go for. She's giving me a bit of creative direction there. Don't think about flowers, think about mushrooms and moss and logs and all these kind of interesting, bits going on there. So we're using depth analysis. You can see here on the right, this is creating normal maps out of the depth map. So we managed to bring that into Pops, and then in Pops you can basically just calculate the normals, and then we could save that out, bring it back in as 3D geometry data, basically. So yeah, and this is the scenes that we were creating using the depth analysis. So this is a 2D image that's been essentially turned into a 3D scan using just the depth maps. And these UI elements on top, this is using some analysis in Pops, which I'll go through very soon. We also did some motion analysis. This didn't make it into the show so much, but this is kind of more of an experimental phase. We had these like flocking of bats and starlings and so on, mainly bats at night, and we were creating connection lines between them as they flock. And we also have some, we were doing like some kind of 3D optical flow, or just sometimes even just kind of creating particles from movement of animals and then trailing behind to create these kind of motion vectory kind of effects. So this is using optical flow on this owl footage, and then we could take that optical flow to advect particles and so on. So we were doing a lot of that stuff with Pops, not a single line of GLSL code. So that's one of the great things about using this new op family. And yeah, here you can see this effect here, this owl behind me is, that's creating particles from the owl's wings and basically isolating the owl to the background and then creating these particles with a bit of noise and a bit of kind of wind flow on there to make it look like the owl's moving in flight, and it almost feels like it's the owl's wings moving. It's not a physical representation of what an owl's wings are actually doing in any sense. It's more of an artistic interpretation, but it looks good, so why not? And then we're doing color analysis. We're taking footage and creating particles from color, and we're actually creating depth maps for the entire edit. So we have these depth maps of everything that we put into the system, so we can just make particles move through the depth of the scene. So quite heavy on depth maps in this project. So yeah, so let's talk about Pops, because that's kind of probably more interesting for you guys. So we have point operators. This is Derivative's own writing, so hopefully it's correct. But yeah, basically point operators is a new operator family, TouchDesigner, creating modified 3D geometry data that runs on accelerated GPU graphic cards or chips. I don't know how many people who've used pops here yet. There's a few. Oh, quite a few. Okay, that's good. So yeah, so I'll just quickly, if I F10 here, we should actually be able to go into this. There we go. So yeah, so down here you can see here, this is the sphere pop. We can create a sphere. And one of the interesting things about pops is that we can have a lot more geometry now than SOPs because we're now on the GPU. We can, process things a lot faster. So this is just a simple example of a pop setup. I've got a sphere. I've got a texture lookup using just the jelly bean example here. And that texture lookup can then just go into some quite heavy noise. And you can see here, it's all running really fast at 60. And looking up textures in SOPs used to be like a really painful process without using, some GLSL or something. And now it's kind of just, there you go, one op, done. It looks great. So they're quite efficient. And, they help us speed up our workflows as well. So the data for pop starts is point attributes, and from points we can work with particle systems, point clouds, polygons, lines, spline curves, and other forms of data. So I'm just going to quickly show you here. So this is, when we did the project, one of the things we realized is that, and I'm sure this is being, I think this is actually, we have had a discussion about this, and I think Derivative are maybe working on something for this. But when loading in point clouds, they don't load asynchronously, they hang the system a little bit. So we were using DDS files out of TouchDesigner and still saving in top format. And then we'll bring those in. We can crop this data. So this is the positional data. This is the color data. And this is the normal information. And we'll bring that in. And then you can see there that we have a point cloud in here using the top 2 pop. And we can kind of just choose which color channels. And then we can assign them to different attributes. So the way that pops work is that attributes are it's attribute wrangling. So you can have, in the old TouchDesigner setup, if people, I think quite a few of you might have followed the kind of tutorials on, how to do particles or use the top workflow where you have to have your position in one top and then your color in another top and then your other information in another top. Now with pops, we can have them just all in one operator as attributes. So here, if I middle click, or in fact, if I go a little bit out, sorry, let me just full screen this. So you can see here it says 3 point attributes there. I've got the position, I've got the color, and I've got the normal, and it's all in one operator. And all the viewers are 3D viewers, so we can easily see the data that we're working with. So in this case here, I'm creating, I'm making this moth, and I'm bringing it into a particle pop. I'm then applying some noise, just basically creating particles from those points, applying some noise to that particle system, and then using, you use a null to end a particle system, so you have a target for that, and then that will, make a loop, essentially, a particle loop, and just sending that out through a merging it with the original data, and we've got a particle system and a point cloud all together in a single op here. And it's super efficient. We can have, depending on hardware, you can have like millions of particles. Like on a 5090 machine, you can have 2 million spheres I had rendering the other day. So it's pretty efficient. So that's what pops are. They allow us to take those workflows and work much more efficiently with them. They kind of replace SOPs. I'm not going to say they replace SOPs because I'm sure there's still some areas where we do need SOPs, but I don't know if there are areas like that. I imagine Greg probably wants you to let him know so they can make a pop version because it is more efficient for processing. And this next example is loading. So here we go. So I'm going to talk about some of the pops that we used on the show. So I don't know if you can, this is quite dark on the screen, but if I zoom in, you might be able to see it a bit better. You can see here we've got all these spheres rendering in real time, and these sort of light spheres. And you'll also see that we have these light rays, which are really hard to see on the projection unless I go to the top here. Yeah, so we have these subtle light rays that are coming from the light source as well. So a lot of rendering engines, you'd have volumetric fog and so on, but these light rays are actually, they're pops. They're actually done in pops. So it's kind of faking volumetric lighting by using the proximity pop. So let me go in and I'll show you how this network works. So in here, we have First of all, this is one of our scans. We actually scanned a tree in Japan, and this is the actual scan of the tree. And then we do some transforms with that, and we basically turn it into this here. And you can see there's the pop using the lookup texture. So I'm looking up the UV coordinates of this model to get the texture back using this texture lookup. You can see that's the UV map for the 3D scan. So this is just what came out of the 3D scan software. For some reason, it was an OBJ with this unwrapped UV map. So we use a lookup texture to apply those colors from the texture UVs directly onto the points. So we get all the points have the correct color for that point cloud. I then apply a little bit of noise to give it a bit of movement and bring it to life a little bit more, give it a bit more sort of movement going on there. And then we use the delete pop. So delete pop lets us, we have the ability to thin out data. So if we want to just not work on our entire point cloud, we just want to work on some elements of it, or have just random points in different places doing things, then we can use the delete pop to thin out that data and give ourselves, like, just in this case, I've only got 100,000 points in this one, which is apparently a small amount compared to before. So and then I'm using that delete pop, applying some noise, and we had this thing where during the show we wanted to create these light beams, but the proximity pop at the time only had one input, and that would basically it's essentially the same of it takes points that are in proximity of one another and makes line connections between them. And a lot of you probably have seen like plexus effects in After Effects or so on. You could kind of create those effects really easily using the proximity pop. You can kind of create those. But for us, we just wanted a single point to connect to all of the points in our point cloud to create these light rays. So we wanted just these lines that were going to connect to our light source. The problem with the original proximity pop, is that there was only one input, and so we had to make sure our light source was really far away, so we could set the minimum distance to kind of only give us points connecting to that light source. But with the new proximity pop, what you can do is you can have two different objects, and you can say, I want this object A to only exclusively connect to object B, and in our case, object B is just the light's position, and we could say, okay, now connect only the points within a vicinity to those objects. So if you have like a sphere and a cube and you want them to connect together through lines, you could say only connect the sphere to the cube, but just make sure that that sphere doesn't have any line connections within its own structure. It only connects to cube points. So that was really useful. It was a really nice addition. That got made, unfortunately for us, a little later, so we had to go over the old version. But now we can make it look great, and then we just render that as a wireframe matte with some transparency, and we get this light ray effect that kind of makes these volumetric lights. So we could have done that in a shader with like some volumetric lighting thing, but like again, if for people who don't want to write GLSL, like I'm not really a massive GLSL script kiddie, if you know what I mean. I'm not really into it. I prefer to do things in operators, and this is a great sort of thing that we could do with that. So we then also use the proximity pop here to do the traditional sort of line connection, like plexus style lines, but where, I don't know if I can zoom in on this here so you can see it. So you can see here we've got these kind of lines that are just thin lines that connect different points of our scan together, so it looks like it's kind of analyzing the tree. So it's analyzing the structure of the tree. So yeah, we have these, and then those get instanced into these little light dots that have a bit of emission on them, and that then gets render pass out, blurred, and then added as a bloom, a fake bloom basically on top with the rays. So yeah, we use a render pass. The render pass just is the connectors and the rays on their own, because we only want them to glow, and then we want to comp them on top. So we use render passes to split out our objects and make sure we have a nice structure there. So yeah, so that's the proximity pop. It's a really powerful one for, if you want to create particle effects which are connecting and doing things. This is actually the most basic use of it. You can get the attributes out of it and then also use it for things like flocking or for, any kind of steering or avoidance or collisions. you can use it as a tool for building those kind of things too. But for the sake of this talk, I'm just going to talk about the simple side, and then you can look at the overview file. The TouchDesigner overview file has a lot of information about that, about how to do the other neighbors kind of stuff. Oh. So the next thing that we kind of did was we used the analyze pop, and you can see here the this like effect, the scanning effect down the frog. So the frog itself is one of our image scans. So you can see here it's a depth map and an image combined, and then we get this point cloud. You can see the detail we're getting just because these are really high resolution images. They're taken with proper SLR cameras, so we can get really high res there. And this is a simple example of the one we had in the show. So yeah, so this is the lines going down, and we use the analyze pop to create this. So I'm going to show you this one now. So again, we have these DDS files, and the reason we did this is because these DDS files we can reload into different animals without dropping a frame. So it's really good for if you have like large point data and you want to switch between, save them out as DDSs. For now, I'm sure there'll be a proprietary format at some point, but for now, this is like a good way to get around that, and it will load them like, instantly pretty much. Because we're using the movie file and it's asynchronous, so yeah, so we convert that using, again, the top 2 pop, really powerful. We convert it all into this nice 3D scan using that. And then we can go down here. And you can see that what I'm doing here is I'm using the delete pop in a different way now. So before I was thinning data, and now what I'm doing is I'm using a bounding box, and I'm basically saying delete everything outside the bounding box. And then I'm using a beat and a limit, and I'm using the limit to quantize the rounds. So quantize the bounding box is position, so it kind of goes steppy, it steps across. And then that stepping across gives us these little segments of the frog that we then want to analyze the position and the size of the frog. So that's how we're going to get that kind of flow around the frog with the structure. So then we use the analyze pop, and the analyze pop is like the analyze, I guess, top or chop, in that it allows you to analyze things like, the average, the centroid, minimum, maximum positions, or in my case, it's positions. Pops can work with any attributes, so it could be with color, it could be with vectors, or forces. You can put any input attribute in here, and it will give you the analysis on that attribute. So in our case, we get the centroids, the minimum, the maximum, and you can see on the bottom left here, whenever you create new attributes, it actually tells you the attributes there. So it's quite handy for being able to see, like, okay, so I created this attribute here, and now I can follow it down the chain. So we create centroid, min, max, convert them into chops because I actually just want to use them as chop data. So we can go back and forward, and we can go back to the CPU with chops and do some things there. You can, I think, get the attributes out using Python, but Greg's nodding. You can do that. I don't know, maybe I was lazy. I just used a pop to chop. And then that gives me, my min and max, and then I'm just using that to create these shapes that follow the bounding box shape. So the bounding box is, if I go in here, the rectangle here, the size is the maximum minus the minimum to get the size, and then the translation is just the centroid. So we're basically saying take a rectangle on the centroid and then move it and resize it as we move down the shape of the animal. And then we also have this. This is just the dot, which is just following the centroid. So that's just the centroid of the scan as we go down is, if I show it there, the centroid of the animal as we go down is that dot of the scan. So obviously this effect relies on the scan being aligned in the correct axis and being not a clean scan there. So, and then finally we add some feedback to create a trail, and then we get our little froggy with his. I think he might be a toad actually. I'm saying frog, but I think he's actually a toad. But yeah, so we go down there and we get that. So that's the first example of using the analyze pop is like kind of you can use it for doing some kind of like graphical effects. Like, you know, that everyone likes that, oh man, the connection effect on Instagram that everyone's doing. You can do it quite easily using analyze pops and so on, and the quantize pop as well. So yeah, so I want to talk about the quantize pop. So the quantize pop is basically the same as like a limit chop with quantize mode turned on, or you know, it allows you to just take the scan and kind of decimate it into smaller cubes and so on. So if you want to do any kind of like de-resing effects or any kind of, you know, sort of making, if you want your point scale to change depending on shapes and so on, you can quantize it, and that will give you something like this. So in this example, I've got my frog again, or my toad, and I'm doing the same, it's the same effect, but in this one, I'm using the quantize pop to basically round all my points to a specific coordinate, and then I'm scaling those using some noise, just give it a bit of movement. Sorry, it's a bit of random scale. Sorry. So this noise, you'll see here on this noise, I'm actually outputting this this attribute here called point scale. So, you know, we can easily create a new attribute, and point scale is how big do I want my points to be in the final render. And then I can send that into some geometry, and I can use, with instancing, I can instance those point scales as my scale parameter for my instances. So what's great now is that in the past, again, with tops, we'd have to have like 5 different tops to do like the translate, the rotate, the scale, the pivot, the color, you know, all of those things have to be different tops. Now we have a single default instance op, and we can actually now have all of those attributes just coming in as one single pop, as opposed to multiple tops. And you can see there it says on the bottom left, I have the P attribute here, and I've got the point scale attribute being created here. It keeps flickering because eventually, at some points, there's 0 points in the system, so it's kind of, yeah, that's where I'm getting the warning from. But yeah, it's essentially adding in that attribute down the chain. And then we use the analyze again, and the analyze just gives us the, you know, the other structures, which I'm not even using, actually. I think I can just delete that out. Yeah, the analyze would be for the other effect, but we're just creating a quantize here. And here's another example of quantizing. So in this one, I'm using, if I go inside, in this example, I'm using a field. So the field pop lets you basically create kind of like a field is just an area of space with a fall off, so you can, you know, affect only what's within that fall off. So actually, I think I've got an example further on which will explain it a bit better. But yeah, the field goes in, and then we use the quantizing to kind of create these points here. So I'm de-resing everything to a grid, basically. So for any like grid-like kind of wanted to connect grids or do like kind of grid sort of effects, quantize pop's super useful there to work with. So then, obviously, we heavily used the particle pop. So the particle pop's changed quite a bit since we used it. So this is when we were using, it started off as the feedback pop, then it became the particle pop a little later, and now we have things like forces and so on added to the particle pop. So it's getting more feature full as time goes on, and I'm sure there's still more to come with that. But this is kind of what we were basically building was this plane, and this plane has our footage on it, and our footage, if I zoom in enough, it's actually quad, so you don't see it, but it's actually made of pops. It's made of particles, points, sorry, and then we're generating particles on top of that using the particle pop. So if I go in here, I can show this. I'm going to check how I'm doing for time. I'm doing okay, I guess. 15 minutes? All right, cool. I'm not too far away. Yeah, all right, cool. So yeah, what we're doing is taking the footage, we can manipulate the footage, create like a sort of, you know, some, in this case, just a threshold. In our case, we're using the depth map and then using a threshold on the depth map. But in this example, it's just a threshold going in. We can then use the top two to convert this entire image just into point data, which is great. Like, it's really efficient. We can just have all of our footage turned into nice particles now really easily. And I'm using the delete pop again, but this time I'm just saying if the alpha channel is 0, then just delete that point from the pop. So we just delete off all of the black here. So we're only getting the color values, like the highlights of the image. And then we can use the particle pop. So what the particle pop can do is it allows us to pass attributes in. So we can say, okay, well, I've got attributes like maybe I've got some normals, maybe I've got some color, or maybe I've got some other information I want to start using in my particle system. We can pass those in using the attributes tab here. So I'm passing in the color. And then if I pass in the color, by default, it's called color. So TouchDesigner has some reserved attribute names like P, N, color. Color being obviously attached to color, so that's going to come in and then just be applied automatically to the particles. So if I don't have that, you'll see that we get white particles because we don't have the color attribute. But then I can go in here and I can just choose from my attributes list, I want some color in my points. So here we go. And then I add some noise in, and it's a tiny little bit of noise because this is in a particle system loop. This section here is the actual full particle system. So what we do is we say, create my particles in the particle pop. I then have my end particles, which is my null, to say this is the end of the loop. And then anything I do in between is going to affect that. So if I increase this amplitude, you'll see that things start to get really crazy. And if I start changing with the period and so on, I can just start advecting my particles with this noise in a really fluid, intuitive way without needing to worry about jumping into 10 billion lines of code. So yeah, so it's quite a powerful way of working. There's also, if I go to my next example, there's also, you can take these particles and then you can take them out and do other things with them. So in this case, I'm using the isolate the owl. In this case, I isolate the owl with just the delete. The owl's already on, the owl footage is on black. So it's already in the dark. So I've just taken a chroma key. Don't know why I do the chroma key because I'm deleting it on black anyway. And then I delete out anything from the chroma key that's set to alpha, and I get my owl. And then I'm just creating particles from my owl. And it's gonna, once those particles get created, they get detached from the owl and they become their own thing. And we can apply some noise into that, and it's gonna give us this nice, owl moving through the air with these particles. I also, in this example, again, just using the quantize pop, I'm using the quantize pop and the proximity pop together, the two I explained before, to first of all create a grid of the owl's movement, like little low poly grid version of the owl. And then I'm saying, okay, let's connect those lines on that grid together. And that's how we get this kind of square box effect that's looks like it's kind of analyzing the owl there. We didn't use this in the show, but I just kind of want to show you can really quickly do things with proximity. And it's quite powerful there. So again, we composite that. It goes into, we have our particles in one render pass, our owl in the second, and then we get that sent out. And then in terms of my examples, I've got two more, Greg. So I've got the field pop here again. So with particles, the field pop's really powerful. You can essentially take a bunch. So these particles here are just on noise. It's a rectangle with some noise, and then we can bring that noise in, transform it in, using this weight attribute, which you can see at the top right there. Oh, have I gone too loud? And the weight attribute is created using a field. So you can see here, the field pop lets me create this effector kind of fall off by essentially setting up it's going to be I set it as a sphere, and it's got a weight, and then I can set how much of the fall off of the weight is there, how strong the field is. So this is actually a visualization of the field's weight attribute. So all I'm doing here is converting the weight to color, and then that then gets sent out as a weight attribute that I can then use in my transform here as a weight attribute. So the transform has a weight attribute parameter on there, so I can say, okay, take the weight of this field and make it so this transform only affects things within that weight. So this is super useful if you're making like an immersive install and you want 20 people in the room to all attract particles towards themselves, and you could say, okay, make them all into fields, take these weights and then combine them together, and you can have the particles kind of interacting with people. So it's quite a useful tool for that. And then finally, I'm going to get on the most complicated one. This is the math mix. So I'm just going to quickly show this one. The math mix pop is really powerful. In fact, it's the most powerful pop. It's probably the one I use the most. And we didn't use it in those examples, but we use it heavily in the show because we were doing a lot of kind of custom attribute wrangling, and the math mix allows you to do that. So in this example here, we take a grid. We use the sprinkle pop to sprinkle random points onto our grid. We use the proximity pop to connect those lines together into a sort of, a new mesh that we're creating. And then we can do a lookup texture. And what I'm doing with the lookup texture is I'm just looking up a ramp, and I'm using the ramp to be like a displacement, essentially, on the pop. So in this case, I've got an output attribute scope here, which is ramp weight, which is there. And then ramp weight can be used in the math mix to modify the position of our points. So in the math mix, what I'm doing is I'm saying, combine the attributes, the positions, the z position, so p.z, which is the z coordinate for each point, add the ramp weight to that point, and then output that as the position. So what I'm doing is saying, take the ramp weight, add it to our position in Z, and then we'll do a displacement in Z, and you get this kind of ramp effect here. And then I just add some noise to make the color. So I'm outputting the color attribute for the noise, and then we send that out to render, and we get this render here. Cool. So the math mix, obviously that's just doing an addition. You can do, sorry, let's quickly show this one last time. You can also, with the math mix, you can set we can divide, we can do max and min, we can do looping and so on, we can do Boolean comparisons and all that kind of stuff. So it's a really powerful operator for doing your own custom kind of attribute wrangling in there. So yeah, this was a very basic kind of just overview of some of the techniques that we use with POPs, but obviously the overview file's super useful. And there's, I imagine at some point there'll be snippets coming as well, which will probably be based on that. Darian Brito has his POPs snippets, which are really great. I recommend everyone who wants to use them go download Darian's file, because it's actually really powerful what he's doing with POPs there. So I would go look at that as actually the first introduction. And he's got a lot of these kind of techniques in there as well as files. So I just want to say thank you sorry, that was a bit fast, because trying to get through 500 things, but thanks a lot, and yeah.